We need to now move on to look at producer behavior. And producer behavior is, how do firms decide how much to produce, how much to charge, how many inputs to purchase, all of those myriad of decisions that a producer needs to make. Now, just like we did with consumer behavior, we're going to start with a very unrealistic model of producer behavior. We're going to start with Old MacDonald's farm. Old MacDonald has a certain amount of inputs. They're going to be producing corn. So Old MacDonald has some decisions to make. The first is, what do they want to do? And we're going to assume to start with that they want to maximize their output. We usually look at total physical product. Total physical product is how much output do you get from inputs. All right. Now, let's look at this. Let's say the input that Old MacDonald is using is fertilizer. Total physical product is the total output they get. So in this chart, you can see that if Old MacDonald uses no fertilizer, they still get 1,000 bushels of corn. It's just drawing on the natural nutrients of the land. But as they add more and more fertilizer, what do we notice? Their total physical product goes up. Now, interesting, but not really anything of surprise. This is kind of like what consumers do, that when we say the more that you get of a good, the more your utility increases. Again, remember, producers don't have utility. All right, but now we need to look at something else. And that something else is our marginal physical product. Our marginal physical product is defined as the change in output due to a change in inputs. So, how does that work? Well, here's an addition to the chart we just looked at. We notice that if there's no fertilizer, we get 1,000 bushels of corn. If we add 1 ton of fertilizer, that gives us a total output of 1,250 bushels of corn. That 1 bushel by itself gave us a marginal physical product of 250 bushels. Right? And what we notice is that as we add more and more fertilizer, a couple of things happen. While our total physical product continues to increase, and we now say up to a point, our marginal physical product also does that. It increases, then it begins to decrease. Now, if you were Old MacDonald and you could keep taking fertilizer, and your goal is to get as much output as you can, how much fertilizer would you take? Well, again, the question is, if we want to maximize our output, we notice that, interestingly, output maximization occurs at 2 points. At 7 tons of fertilizer and at 8 tons. So the question is, which of these is the optimal amount? Just as what we saw when we looked at consumer behavior, we realized that after we take the 7th ton of fertilizer and put it on our lawn, on our crop, we see that we get 50 tons of additional output. Now, it's not until we put the 8th ton down that we see that we're getting the same amount of output. So we don't know when we take the 7th, what's going to happen when we take the 8th. But when we take the 8th ton of fertilizer and we see that it gives us no additional output, we definitely want to stop here. We don't want any more inputs. We know we've maximized our output. Even if we don't put the 9th ton on, we know what's going to happen. We've already seen the law of, we see that our additional output is dropping. So once we hit 0 here, it makes no sense to add another ton of fertilizer. So what we realize is that the optimal amount of inputs to take is where the marginal physical product equals 0. And this is what, if we were to graph that marginal physical product that we just saw, this is what we'd see. We see that in the beginning, we go up, and then we go down, and yes, we do go negative here, right? What we see is that there are 3 distinct regions of this graph. One in which the marginal physical product increases, and if you flip back to the slide before, you'll see that corresponds with tons for the first and second ton of first, second, and third tons of fertilizer. Once we get to the third ton through the 8th ton, we see a decrease in output. With the 9th ton, we see fertilizer becoming, or output becoming negative. So what about these 3 regions? Region 1 here is a region of increasing marginal returns. As you increase inputs, additional output increases. We also see region 2, which is a region of decreasing marginal returns. As you increase inputs, additional output decreases. And region 3 is a region of negative marginal returns, in which as you add inputs, additional output or even total output drops. Now, as a producer, which of these regions would you want to be in? Well, I can see being in 1 and 2, but unless I want to lose money, being in region 3 doesn't make any sense. Although sometimes businesses may work in region 3. It could be if you want to, say, gain market share. You're willing to lose money temporarily in order to produce more to get more of a share of the market. Sometimes in developing nations or where governments require firms to have a certain number of workers, even if those workers don't add to output, that could be moving in region 3. So for most producers, you want to be in regions 1 or 2. But what you have to keep in mind is the law of diminishing marginal returns. What we know is that as you increase inputs, additional output will eventually decrease. So keep that in mind. So something else has to go into the decision-making process used by producers besides just inputs. There has to be something else that we look at. And most producers are going to do, or most businesses are going to do what we consider a cost-benefit analysis. That is, compare the cost of doing something with the benefit of doing it. You know, those scales of justice, those 2 pans, they have to equal out. Now, when we look at the benefit of adding additional inputs, we can look at that benefit in two ways. One we've looked at, which is the marginal physical product. That's the additional output you get. But as you add more inputs, you're going to get more revenue, right? You get more output, you get more revenue. So when we're looking at the revenue you get from an additional input, we call that marginal revenue product. Marginal revenue product is defined as the change in revenue due to an additional input. And so this is the formula for marginal revenue product. Please remember that that triangle that you see here is the Greek letter delta. And delta is the term we use both in economics and in other sciences to represent the word change. So the marginal revenue product is the change in revenue due to a change in output times the marginal physical product of the last input. If we're using cost-benefit analysis, we're going to see that the marginal revenue product of the last input has to equal the price of the last input. If I'm hiring workers, the additional revenue that last worker gave me has to equal the price that it costs me. So if you're purchasing one input into production, you would keep purchasing that input up to the point where the revenue it gives you equals what it costs you to buy that input. Now, we also need to look at the production functions that we have. A production function are various combinations of inputs that give us the same output, that maximize our output. And so when you're trying to decide, if you're Old McDonald and you have 7 tons of fertilizer that you need to put on your ground, you would buy fertilizer up to the point where the marginal revenue product of the last ton of fertilizer equaled the price of that last ton of fertilizer. But remember, it's not only just fertilizer, but you need labor to spread that fertilizer. So you need to know, am I buying the correct combination of fertilizer and labor? So if you're buying just fertilizer, you know you've purchased the correct amount if the marginal revenue product of fertilizer equals the price of fertilizer. If you're buying only labor, you know you've purchased the correct amount of labor if the marginal revenue product of labor equals the price of labor. But that's buying them separately. You need to buy them together. So we do what we did with the marginal utility when purchasing two goods. We make a ratio. So we know that the marginal revenue product of fertilizer has to equal the price of fertilizer. The marginal revenue product of labor has to equal the price of labor. So if we're buying them together, we create this ratio. And if we do a little algebraic manipulation so that we can get all of the things about fertilizer in one ratio and all of the things about labor in another ratio, we end up with the criteria for the optimal amount of labor and fertilizer to purchase. We know we've got the correct combination of two goods if the ratio of the marginal revenue product of the first good divided by its price equals the marginal revenue product of the second good divided by its price. All right? We now have to go look at the other side of the scales here, and that's costs. But we're going to have to move that to our second lecture.